All right, jumping into kinematics here. So kinematics, we start with the distance from a velocity graph. So what this concept is this is how we're going to dip our toes into kinematics. Is if we think about this graph here. So I've sort of drawn this function here, and it represents, I haven't written units on it. It represents us going at 60 kilometers an hour and considering the time along the bottom. And so if you think about just driving in a car, if you are driving at 60 kilometers an hour and you've been going for 1 hour, you've gone 60 kilometers. And so 60 times 1 would give us, the area here would give us how far we've traveled in 1 hour. If we're going 60 kilometers an hour and we go for 2 hours, we've gone 120 kilometers. So we're looking at that there. So this here, if I think about it, if I do the integral of 60, which is my velocity here, my velocity function, and I do with respect to time, we're going from time 0 to t, this ends up giving me a function here, which is 60t because of what we've done, with a lower bound of 0, or I should change that to the notation we're used to using. T equals 0 and t equals 1. No, what are we doing? We're doing 2. Sorry. 2 and 2. Let's change that to t equals 0. And so if we're just thinking area-wise, we know that this here would be 60 times 2. But we should also notice here that we end up with 60 times 2 is our upper bound minus 60 times 0. All right, so that there would give us 120, which is our answer here. So we're sort of looking at these different things. This area here, if we were looking at this velocity function, is 60 minus 600t. If I consider calculating the area here, you'll notice the base of this thing is 1/10. The height is 60, and so let's just do base times height divided by 2. The area of this shape would be 1/10 times 60 over 2, which would equal 1/10 times 60 is 6 over 2, would equal 3 kilometers. So if we're going 60 kilometers an hour and we've gone for 1/10 of an hour, we've gone 3 kilometers. Okay, so this just brings us to this formula for the velocity function vt, where the velocity function is greater than 0 on the interval between 2 times. We can do the distance we travel will be t1, the integral of t1 to t2 of the velocity function with respect to t. So just, this isn't much from this. Now, I've just thrown this in. Previously, we realised that in kinematics previously we've done displacement. If we take the derivative of that, we get the velocity. If we do the derivative of that, we get the acceleration. And we've practiced in this previous section, if we integrate, we're doing this step back here anyway. So this shouldn't be a huge surprise, this step back that we're doing above formula. We should sort of expect that this is going to give us these values. Now, the next section here, I'm just going to use the example because it's just getting us used to using velocity graphs and considering the distance. So the velocity time graph for a train journey is illustrated in the graph alongside. Find the total distance travelled by the train. So we're looking here, the train's gone 50 kilometers an hour for 0.1 of an hour. So you got to remember that 0.1 of an hour is actually 10%. It's actually 6 minutes. So this one here, we've done 1/10 of an hour. So this particular area here, we'll label it A. A would equal 50 times 1/10 over 2, which would mean this thing here equals 5 over 2, which would equal 2.5. I'm just doing it this way. This next one here is this big square. This square, we'll call this B, is going to be 50. So we're going to go B equals 50 times 2 over 10, because it's 2/10 over 2, which is going to give us 50 divided by 10 is going to give us 10 over 2. Hang on a second, have I done that right? 50 times 2 over 10. 50, and that's times 2. I cancel. So the 0 and the 10 will cancel out here. So this thing will just equal 10. This next section here is a trapezium, so a little bit harder to do, but we've got to add the two different sides. So we'll call this one C. So C is going to equal 50 plus 30 over 2, and that will be times by the height, which is 1 over 10. So we're going to get here 80 over 2 is going to be 40, times a tenth is going to be 4. So let's do 40 times 1/10 equals 4. Okay, the next one here, we can even see this one here. It's going to be D here. I'm running out of room. I'm going to have to go up here. D equals, it's 30 times a width of, that's the length times width. So it's going to be 3 here. And then E is our last one. Now I'm just going to move these. This is just getting a bit much. Okay, D. Let's quickly do E. Okay, E is this final one here, which is going to be 30. It's got a height of 30 times by 1/10 over 2. It's going to equal 3 on 2. Now we need to add all these up. So I'm just going to quickly do it in the calculator because these are they're not crazy decimals. So we've got 2.5 plus 10 plus 4 plus 3 plus 3 on 2. I get 21 kilometres there. So A plus B plus C plus D plus E equals 21 kilometres, which is the area under the curve there. All right, that's it for that section. So nice quick one, I hope.